Good morning. So this whole next unit is about solving equations numerically. And what that means is solving equations in cases where I can't necessarily just get an x by itself. All right, here's what I mean by that. Let's say I started out with this equation up here, this e to the x equals 1 over x. Well, one thing I might try in order to get these things by themselves is to take natural log of both sides. So I'd get natural log of e to the x equals natural log of 1 over x, which in fact I can do right here. And obviously the ln and e to the x undo each other, so that would just equal x. Here I can rewrite the natural log of 1 over x as ln to the x minus 1, and I can do the negative down there. Now notice, right here, I haven't got an x by itself because I've got an x on this side and an x on this side. What are the things I could do? Well, I could try to get this one isolated by making e the base of both sides, but now look, I'm going to end up right back where I started here. And there's simply no algebraic way to isolate the x where that we can see x equals 0.5729 or whatever it's going to equal. All right, so we might have to do a little bit of analysis here to try to narrow in on what exactly x equals. What's the x that solves this equation? All right, over here, I have a graph of both of these things. So if I think of these as two separate functions, over here is one and here's another one, and I want to see where do they equal each other. Well, this is a graph of y equals x. So these are all the places where y equals x. And then here is a graph of y equals negative ln of x. All right, and the place where this equals this would happen right here. All right, so wherever this x is, that's the x where those two things are going to be equal. All right, so now to figure out where exactly this is, what I need to do is sort of have a general idea of where it is. All right, and if we graph both these things, we see that this is somewhere around 0.5. Okay, and now what I'm going to do is I'm going to create a function that is going to do one of these minus the other one. Because if you notice, like out here, right, if I did this function minus this function, I would get that amount. And out here, if I did this function minus this function, I would get that amount right there. Wherever I get an amount equal to 0, that's where they equal each other. Okay, so what I'm going to do is do this function minus this function. So I'm just going to do x minus negative ln of x. So that becomes x plus ln of x. And wherever this equals 0 is going to be where that root is. All right, so I said before that if we graph these, we could see that this is somewhere around 0.5. Now, what we notice here is that like as these things are crossing each other, on one side, this is bigger, and then on the other side, so on the left side, this function's bigger, and on the right side, y equals x is bigger. All right, so what's going to change in between there is if I'm out this way, right, this minus this is going to give me a negative number because this is smaller than this. Whereas if I'm this way, this minus this is going to be a positive number. So by plugging in this point, I know it's somewhere around 0.5. When I plug that into there, if I get a positive number, I know that I'm actually on this side of where the actual root is. And if I get a negative number, I know that I'm actually on this side of where the root is. So let's see what happens when I plug this in. So when I plug this in here, I get negative 0.193, and I'm not going to write the rest. Okay, but I got a negative number. All right, well, since I got a negative number, that tells me I'm over on this side of where the actual root is. So what I know is 0.5 is somewhere to this side of where it's at. Okay, now here's what I'm going to start doing over here. Over here, I'm going to write down some things. So I've got ones that are on the negative side and ones that are on the plus side. All right, and this is going to help me kind of narrow down where I am. So when I plugged in 0.5, that was on the negative side. Let's try 0.6. Okay, if I plug those things in there and do 0.6 plus ln of 0.6, I get 0.089. All right, well that's positive, which tells me that 0.6 was over here on the positive side. All right, so what does that tell me? That tells me my root is somewhere between 0.5 and 0.6. Okay, well let's try to narrow this down a little bit. Well, somewhere in between here is 0.55. Let's plug that in. All right, when I plug that in, I get a negative 0.04. That was over on the negative side. So I know 0.55 is over there. So now what do I know? Now I know that my root is somewhere between 0.55 and 0.6. All right, what's some number in between there? I'm going to pick 0.575. If I do that one, I get 0.02. So that tells me that one's over here. All right, so see now what I'm doing here is kind of like picking numbers and then seeing whether they're on this side or this side. And the more I do this, the more accurate that I can get. All right, between those two is 0.565. So let's check where that one is. Okay, that one's negative. It was negative 0.006 to be exact. All right, well now I know it's between these two. Well, let's try 0.570. If I do that one, I get a positive. So that one's over here. Okay, from this point, it's just a question of how accurate do I need to be? If if I only need to be to like 2 decimal places, then I'm already there. This rounds to 0.57, this rounds to 0.57. So if I only have to go to 2 decimal places, I'm far enough. Let's say I want to go to 3. Okay, let's say I want to go to 3 decimal places. I'm not close enough to know that yet. Okay, if I plug in 0.57, I got a positive 0.07. All right, that was over here. All right, so now what I want to know is like, I want to sort of like keep narrowing the distance here. So this is 0.565, this is 0.570. What's halfway between those two things? Maybe 5.67 or 5.68. I'm going to check 0.567. And I'm just literally putting things in a calculator here. That gave me a negative. So that was over here. Okay, so now I know it's between those two things. All right, let's check something between here. Let's check 0.569. And that's a positive. Okay, let's check 0.568. That's also a positive. Okay, now I know it's between these two things, so I'm going to check 0.5675. That's also a positive. Okay, now once I'm to this point, so I know this is too much on the plus side. At this point, I know everything in here is going to round to 0.567 because I know it has to be smaller than this, and I know it has to be bigger than this. Everything that's bigger than this but smaller than this will round to 0.567. And now I have it to the nearest 3 decimal places. We could keep going. We could keep going like this forever and ever, and it just is a question of how accurate that we want to be. Okay? This incorporates this method of finding the root is called a decimal search, and it uses something called the sign change rule. Okay? All right, basically what the sign change rule says is that if there's a root for a function, right? Um, if a function's continuous, between, let's say, P and Q, all right, so if there's 2 points on my function, and f of x is this nice smooth curve between P and Q, and f of P is less than 0, while f of Q is greater than 0, then f of x must equal 0 somewhere between P and Q. All right, that's just sort of formalizing what we did here, right? So we knew that there was a negative here and a positive here, so the root has to be between the two. So we narrowed it in. Let's check between this one and this one, right? This one's negative, this one's positive, so now I know my root has to be between those two things. And then I just kept going in there and narrowing it down until I got as accurate as I needed to be. Obviously, this method of doing a decimal search isn't super efficient if I want to go to like 10 decimal places, because this is going to take forever. And so in our next section, we'll talk about using iterative formula to find the numeric solution for x. But for today, you're just going to be working on using decimal search. All right, so your assignment for today is in 8A, and you are going to do numbers 1, 3, 4, I, and 4 and 4A. Do parts 1 and 2 of that. Okay, so it's really only 3 problems, 4 if you count the subparts on this one, and then, but each one takes a while, as you've seen. Okay, and then I will be back on Wednesday to go over this, and we'll talk about iterative formulas.